Welcome students. We'll begin with the new chapter, Magnetic Effects of Electric Current. Now in the previous chapter of electricity, you've already studied about the heating effect of electric current, right? You've already discussed that how the flow of the current generates heat. But in this chapter, we'll study about the different aspect of electric current, where we'll understand how an electric current give rise to the magnetic field. Okay, in your junior classes, you must have discussed or you must have studied about the magnetic effect, that what is a magnet, right? So if you have a bar magnet, it has a special property that it can attract iron nails or iron fillings towards itself, right? But there are those common substances that have, or there are substances which are magnetic in their character. Okay, suppose you take a bar magnet. Now, bar magnet is made out of a magnetic material which inherently or naturally has the magnetic property. But we can also generate magnetic property. And one of the method of generating the magnetic property or magnetic effect is using electricity. Okay, so we'll understand about that in great detail in this chapter. Let us begin. So, first we'll discuss that when electric current flows through a wire, okay, if you have electric current flowing through a wire, it generates a magnetic field. It generates a magnetic field around the wire. Thus, an electric current carrying wire behaves like a magnet. Right. So, some of the properties of the magnetism or the magnetic property is acquired by this electric current carrying wire. That is the effect of the current, right? See, if you happen to see the magnets, those are the magnet, generally they are of the permanent nature, right? Suppose you take a bar magnet. So, it will always act like a magnet only, right? You have not created magnetic field inside it. It was there naturally. But over here, if the current is not flowing through the wire, you will see it will not have magnetic effect. It will not have magnetic property. But once the current starts moving into the wire, it behaves like a magnet. That is the special property of the electric current. So, in order to understand that how the current is generating magnetic effect, or how the current in a wire is becoming a magnet, we have an activity. So, in the activity is to study the magnetic effect of electric current. So, we'll have a look at the animated video and then we'll discuss what has been happening in this activity. Okay, just have a look at the video.
To show current flowing through a conductor, make it a magnet. Take a straight and thick copper wire PQ and connect it in series to a battery through a plug key and a 2 ohm resistor. Place a magnetic compass near the copper wire PQ and note the direction in which its north pole is pointing. Plug in the key so that the current flows through the circuit. You observe that the compass needle shows change in position. Switch off the current. You observe that compass needle returns back to its original position. From this activity, it can be concluded that the conductor behaves like a magnet on the passage of electric current.
Let us discuss learning from the activity. Now, what have you done in that activity? You saw that if the wire was having current in it, the magnetic compass showed the deflection. And whenever the magnetic compass is showing you the deflection, that only means that is a perfect proof that magnetism has occurred in the vicinity, or in the proximity of the magnetic compass, magnet is there. Okay, that's what the deflection in the magnetic compass means. So, what is our learning from the activity? We have seen when current starts flowing in the circuit, needle deflects. The magnetic compass needle, it showed a deflection, showing change in the magnetic field nearby a copper wire. The copper wire was placed near the magnetic compass, and the deflection there showed that yes, copper wire has acquired a magnetic character. From this, we can conclude, very important. What is our conclusion? The wire carrying current produces a magnetic field around itself, thereby exhibiting magnet-like behavior. Just a simple wire. This was a wire. Initially, it was not a magnet. Once you have a current flowing through this wire, it behaves like a magnet. Okay, so that is the importance of this activity. Next, thus electricity and magnetism. See, electric effect is a different effect, right? Electric effect is due to the charges, positive charge and positive charge they repel, negative charge they repel, like and unlike charges they attract. Electricity arises due to the flow of the electrons. It is a completely different effect. And magnetism is another different effect. Magnetism arises due to the magnetic character, right? It gives rise to a different property. But from this experiment, we can conclude that electricity and magnetism are linked to each other. That means both are connected. Electricity is there, that means there is a possibility of getting magnetic effect or magnetism. Okay. Thus, the study about electromagnets, in this chapter, we will study about the electromagnets, which involves magnetic effect of electric current. See, what is electromagnet? Let's discuss this term, electromagnets. It is coming from the term electro plus magnets, right? That means electro means electricity, right? That means the magnet which is due to the electricity, that is called the electromagnet, right? That means you are getting a magnet because of the electricity that is passing through that material, okay? So, we will study about the electromagnet, which involves the magnetic effect of electric current. Okay. Now, if you think about the term electromagnet and you just ask yourself that why are we even studying about this, right? It's a complicated effect, it involves different type of rules, it will involve different type of understanding. Why are we even discussing it? So, you will be surprised to know that most of the appliances are gadgets that we are using these days, they are based on the electromagnetic effect. Okay, the current supply that you are getting, the electric current that is coming to your home is generated at a different place, and its generation is based on this effect, electromagnetic effect. You must have, if you go in the higher classes, you study about the electromagnetic induction. Okay, that property is used for generating AC currents, and that AC currents are coming to our home. That is why we have all the electrical appliances running. Even our, air conditioners these days, they also work on the basis of electromagnetic. The internet that is coming to your house is using fiber optics. And fiber optics is very common these days for the uninterrupted supply of the internet, and especially in the era of 5G. And that fiber optics is also based upon the principle of electromagnet induction. Also, if you see the the hyperloop or the trains that are coming these days, bullet trains, or even for that matter, Tesla has get into the hyperloop concepts where train are flying on the tracks. Those equipments, such a high advanced equipments, those are based on the principle of electromagnetic induction. Electricity is supplied to such a high level that it is able to run huge trains at a very high speed. So such a humongous application is of this concept, electromagnetic induction. Also, if you're curious, you can also read about the Higgs boson, in the European countries, the CERN experiment, the experiment which is going in the CERN. They are using very powerful electromagnets to study these particles, Higgs bosons. Okay, so those are the varied application, even at the commercial level, even at the research level, even at our household level, the use of electromagnetism is very vast. Next, this is now, as we have discussed about the magnetic effect of the electric current, and we have seen how a current carrying conductor or a current carrying copper wire is behaving like a magnet. You will be surprised to know that the scientist Hans Christian Ørsted, he was the first person who discovered this effect. That is why, the experiment that you studied is sometimes also called Ørsted's experiment, because it was him who first discovered it, and that too accidentally. He accidentally discovered such a remarkable phenomenon of electromagnetism, or the magnetic effect of the current. So he discovered that electric currents create magnetic field, which was the first connection found between electricity and magnetism. When you go in the higher classes, you will see that these are the two different branches in physics, electricity and magnetism. He was the one who established a relation, a connection between electricity and magnetism. He accidentally discovered that a compass needle got deflected when an electric current passed through a metallic wire placed nearby. So during his experiment, the current was passing through the wire, and it was accident that the magnetic compass was lying nearby, and he was so vigilant that he saw, why is there some deflection? And in science, it is very important that you question yourself. You observe the things around yourself and you question yourself that why is that happening? And that curiosity, that question has given rise to such a remarkable principle. So all of us need to inculcate that attitude, that we observe things around us and we ask ourselves as to why is this happening, or what is the reason behind it. And that was Hans Christian Ørsted, who gave rise to the electromagnetism. So he accidentally discovered it, and the experiment in the activity that you have studied is based upon his understanding.